In today's video, we're going to look at the second part of our logarithms topic. So last time we looked at logarithms, their base, the argument, and how we can actually draw the graphs, and also the transformations of any of those graphs of the logarithm functions, depending on whether that base a was between 0 and 1 or whether it was greater than 1. What I want to look at today is a couple certain types of logarithm functions, and then look at actually solving some logarithm equations. So, first of all, I want to introduce two different types of logarithms to you. The first one is called the natural log function. The natural log function is just a logarithm with base e. So e, as we looked at in our exponentials section, was that random constant that was roughly equal to 2.7. And so we also said that exponentials and logarithms are actually inverses of one another. And you find that the exponential that has that base e is actually the inverse function to this natural logarithm function. We actually tend to use a shorthand for a log base e, and that is ln for natural logarithm. So ln is what we actually use for the natural log functions. Whenever you see ln, it just means log base e, and then that argument is whatever number b that you have. The other log function that you have to be aware of is called the common log function. And the common log function is just a log base 10. And again, for a shorthand, if you ever see log, but it doesn't have a base, it just gives you log and the argument, that means that we are using the common log function. We're using a log base 10. Okay, so keep that in mind. We have our natural logarithm function, which is the inverse to the exponential function with base e. And then we have a common log function, which is a log base 10. Okay. A couple quick examples of using these. Let's say that you are asked to find the natural log of e to the 1/2. Okay. So that's log base e of e to the 1/2. That's asking what power do I have to raise e to get e to the 1/2? Well, obviously that's 1/2 because e to the 1/2 will equal e to the 1/2. So the answer is 1/2. Another problem we could have is using our common log function and asking for log of this number 0.01. So that's log base 10 of 0.01. So that's asking what power do I have to raise 10 to get to 0.01, which is -2. Okay. One other thing that can be useful whenever you go through logs is actually changing the base. Okay. Normally when we look at logs, we have log with a base a of some argument that we'll call b. Okay. A can be any random base that we're looking at, okay? But it can be very useful to change it. So rather than having log of a random base, to actually change it to have either log base e or log base 10. This will come up more later, but for right now, we're just going to look at how we do this. And there is actually a formula for this. Let's say that you want to write this as log base c. So c could either be 10, it can be e, it can be another value that you have. This is equivalent to saying log base c of the argument b over log base c of the argument a. So if we ever want to change a log from being log base a, so we no longer want a to be our base, but we want c to be our base, then we can actually write this log as log base c of b and log base c of a and do a division. Like I said, c is normally going to be either e or 10, because normally you're going to want to write things in terms of log base e, our natural log, or log base 10, just because they can make our, whenever we need to work these out, you can sometimes do those in your head, whereas if you've got really random numbers, it can be more difficult. So that's where it can be useful. I'm going to go through a couple examples of doing this, but like I said, we will come back to this later. It's just that this is what we're going to use right now, so that then it will be easier as we look at logs later on. So let's say I want to change log base 3 15 into a log with base e. Okay, so that's like saying log base 3 of 15 is equal to, using our formula here, I'm going to take c to be e. Okay, so I'm going to have log base e of whatever b is, which is 15, that's our argument, over log base e of a, so whatever our base was in our original statement. So log base e, like we said, can be written as ln. So I can also write it like this. At that point, you can put it into your calculator if you want. You could also put the original one into your calculator, but like I said, we will come back to this later, and it will make some of our calculations a little easier. Another one that I will do is taking log base 1 over 4 of 20 as a log base 10. Okay, so same idea again. I start with log base 1 over 4 of 20, and I'm changing it to a log base 10. So it's log base 10 of my original argument over log base 10 of my original base. And we can write our common log as just dropping that base 10. And I can rewrite it like that if I want with notation. Sometimes you will be asked to solve log equations. Okay, there is a specific way to solve log equations. I'm going to do this by an example, and then we will write out how to do this and do a few more examples after that. Let's say you're asked to solve log base 3 of x is equal to 4. Okay, and I need to solve this for x. The way that you do this is you're going to raise both sides as a power of whatever your base is. Okay, so my base in this particular scenario is 3. So I'm going to do 3 to the power of my left-hand side equals 3 to the power of my right-hand side. So I raise both sides as a power of whatever my base is. Okay. 3 to the 4 is 81, so we can simplify our right-hand side. What about our left-hand side here? 3 to the power of log base 3 of x. Okay. What does log base 3 of x mean? It means that I'm looking for the power of 3 that gives me x. Okay. So log base 3 of x is saying what power do I need to raise 3 to get x. Okay. Well, once I've found that power and I do 3 to the power of whatever that is, I get x back. Okay, so this is log base 3 of x is asking me what power do I have to raise 3 to get x. So it's asking me what value, let's call it y, gives me 3 to the power y equals x. Well, if I then take 3 to the power of that value y, I should get x back. So what this does, by raising it as 3 to the power of that log, I actually reduce it to just x, giving me x is equal to my right-hand side, which is 81. That's why we do this. So whenever you get a log equation, what I want you to do is to actually raise both sides to the base power. So to solve a log equation, simplify it by raising both sides to the base power. Okay. Let's do another example. This time I'm going to solve log base 4 of x is equal to 1/2. Okay. This time my base is 4, so I'm going to raise both sides to a power of 4 to that particular side. So 4 to the power log base 4 of x is equal to 4 to the power 1/2. Okay. 4 to the power 1/2 is just the square root of 4. I'm going to take the positive square root here, and I'm going to say that that's 2. And then I've got 4 to the power of log base 4 of x. Again, log base 4 of x is asking me what power do I need to raise 4 to give me x. Well, if I then raise 4 to that power, I get x back. So x is equal to 2. Let's do another one. This time I'm going to solve log base x of 125 is equal to 3. Okay, this one looks slightly different because my unknown is actually my base, but I'm going to follow the same rule again. Okay, I'm going to raise both sides as a power of my base. Okay, log base x of 125 means I'm asking what power do I have to raise x to get 125. If I raise x to that power, I get 125 back. So that's just like we normally do, is equal to x cubed. What value cubed gives me 125? That's 5. 5 cubed is 125, so x is equal to 5. So no matter whether your variable, your unknown, is in your base, it's in your argument, wherever it might be, it's easy just to raise both sides to that base power, and then you can go ahead and solve either way.